Hello everyone. In this video, we'll provide the course for developing generative AI application using LangChain. Actually, LangChain is a framework for developing applications powered by language model. It provides a set of tools, abstractions that make it easier to build complex LLM-based application. Actually, in this video, we'll show you how you can invoke LLM, how to send a prompt, how to get a response, how to analyze the response, how to calculate the cost of your LLM invocation. So we'll start by installing the environment. I create the required packages in requirements text file where I install these modules using Python or the command pip install -r requirements to text. This is a list of the modules that I use for developing this application. Um Also, I created environment file where I configure my OpenAI key for Grok, okay, so that I can call the LLM and other configuration in the environment files. Let's clarify some concept related to the temperature and the top sampling configuration settings that I send to the LLM. What is the meaning of temperature and top B sampling? Actual temperature parameter I send it to the LLM. It controls the randomness or creativity of text generation. For example, if I set the temperature value to 0, it has a range of values actually from 0 to 1. If I set it to 0, that's mean the response output from the LM will be deterministic. Okay, so lower value, it's more focused deterministic output, but higher value, okay, for example, zero point 0.7 to 1, okay, you get more diverse creative output. Actually, so the value of this parameter temperature, it affects probability distribution of possible tokens sent by the LLM. Another configuration parameter called top B. It's alternative to temperature sampling. It has a range of 0 to 1 also. It considers only a subset of tokens whose cumulative probability mass reaches the top B threshold. Example, top B it has zero point 0.1, considers only the top 10% of the most likely tokens. It allows for dynamic vocabulary selection based on context. Uh, Actually, we have some other concepts where we have perplexity. It measures how well the model predicts the text. Lower perplexity indicates better prediction. Beam search techniques to find the most likely sequence of tokens. Lens penalty encourage or discourage the model to generate longer or shorter sequence. So in this table, we clarify the values, different values for temperature and top B, because we use the two parameters in the same vacation input. Where, for example, if I set a low value for temperature, that's mean the output from the LLM will be focused, convenient, adhering to code. Okay, where I have different use cases, okay, and the better values for temperature and top B. Okay, for creative writing, for example, I set higher values. Okay, for chatbot response, I set to zero point 0.5 for both for balanced coherence and diversity. Okay, and we have also advanced techniques for fine tuning, where I adapt the model to specific tasks or domains for better performance, like in the medical field. And the prompt engineering is very important. Okay, we will show you in this video how I can manage the prompts. Future learning, where I provide examples in the prompt so that I can learn the context of the model itself. Okay, but I should be aware of potential bias in the model response. and implement content filtering for sensitive applications. For some performance, I can use caching and implement request batching and consider a smaller model for faster response. So let's start, okay, to show you the code itself. Actually, I start my LangChain code by importing the required modules for developing this application. I import the operating system and .env to load the environment file. Okay, and here in this code, I use chat grok, so I import from LangChain grok, and also I use the prompt template for model invocation, this module. So I first start my code by loading the environment, okay, and define my LLM here. Okay, the model name is Llama. It's a 3.1 8 billion instant. Okay, it has temperature of zero point 0.1. That means it's more deterministic. Okay, and this is the API key for chat for Grok API key so that I can call this model. Okay, I use this key by registering to Grok. Okay, so after my registration, I got the API key and I store it in the environment file. That's why I load the environment in this code in load underscore dot env. Okay, here I provide keyword arguments for the model invocation. I send the temperature, then I send the top b zero point 0.5 to balanced value and seed to this number. So I run this code. Okay, so the code runs successfully in. Then I start, okay, the basic concepts here of LangChain. Okay, it introduces several key concepts here where I have a chains of calls. It's a sequence of operations to be performed by the LLM. I define a chain. It's a sequence of operations. Okay, and also I have agents. It's autonomous entities that can be use tools and make decisions. Okay, and memory. Okay, it's systems for storing and retrieving information across interaction. But I will show you here the chain. How can I call the LLM? We focus on simple chain actually. So your first chain application, let's define a simple chain actually for LLM invocation. How can I call the LLM? Okay, for example, here I I already got the LLM from ChatGrook code above here. This one for the LLM for using the class for ChatGrook. Okay, so I call the invoke method. Okay, and here I provide the prompt. Some prompt is, for example, I give him a simple question. For example, I ask the LLM, what is the difference between LangChain and LangGraph? Okay, then I call the LLM using invoke method. Okay, and I get the response back and they print the response content. Okay, simply if I run this code, okay, then it runs successfully. Then I got the response here from the LLM. Look, what is the LLM says? Okay, I couldn't find any information on LangChain or LangGraph. However, I can provide some general information on the topic. Okay, to provide some description for the LangChain and LangGraph. Okay, this is okay general information for LangChain. LangChain is open source Python library for building conventional AI application, and LangGraph is more advanced actually framework. Okay, it's extension of LangChain. Okay, so the LLM replies successfully, but I have some output actually here from the LLM from this invocation. Then I wanted to provide a template, okay, a prompt template for the LLM. Okay, I want to send the parameters. This I wanted to make the invocation more dynamic. So here I provide a prompt template for the LLM. Okay, for example, here I define a template, okay, where I provide a context of the LLM. Okay, I say to the LLM, you are AI architect, provide a context for the LLM. Okay, and I provide him here a template, a prompt as a parameter, okay, for the LLM so that I can send it dynamically to the LLM. Okay, And here I define the prompt template, okay, where I provide him the template that I defined here for the prompt, okay, and the input variables for the prompt itself, okay. And here I create a chain, okay, storage chain, okay. So the chain starts by defining the prompt that I defined here, okay. Then I invoke the LLM after that, okay. And I define a story template. Okay, for example, I ask the LLM, how can I improve the performance of big 7 millions LLM while using a small 1 billion LLM? Okay, this is very deterministic question. Okay, that needs a configuration parameter, temperature, it's point one. That's why I define it. Okay, so here I use the storage chains that I defined here. Okay, okay, and I invoke the LLM defined, okay, using the story template defined above. Okay, then from this invocation I got the result, okay, and print the result from the LLM. And also, okay, I wanted to calculate the cost, okay, from the input tokens, output tokens, and total tokens for LLM invocation, so that I can predict my cost, AI cost from this invocation. So that's why I here I want to print the tokens used. Okay, well I print token tokens and the input tokens from the token usage, the prompt tokens defined from the response returned back from the LLM, and the token tokens from the same array token usage, and the completion tokens, okay, from the output tokens defined. So when I call this code, okay, I got the response from the LLM invocation. Look how the LLM here replies to my question. Okay, it sends a response to improve the performance of large 7 millions parameter LLM while using a small 1 billion parameter LLM. It provides you, okay, how can I improve this performance where the response is very deterministic. Yes, I can use knowledge distillation where I can train the smaller LLM to mimic the behavior of large LLM, or I can use pruning where I can remove redundant or less parameters from the large LLM to reduce size. And I can use knowledge transfer, use a smaller LM as pre-trained model and fine-tune it on a specific task. And I can use also model ensemble where I combine prediction of both LLMs to leverage their strengths and overall performance. And I can use also hybrid approach, okay, where I can use a smaller LLM for tasks that require less computational resources and a large LLM for tasks that require more resources and complex calculation. This is the response I got it for my prompt from the LLM itself, okay, which is very correct and very deterministic. And after that, I wanted to calculate my cost. I want to know what is the total number of tokens here. Here is the total number of tokens used, and here is the input tokens I used, and here is the output tokens returned back from the LLM, so that I can calculate my cost, how much my cost is it. Okay, this is the output returned back from the LLM. Okay, this is actually a showcase for you. Okay, how can I call the LLM? How can I send a prompt template? Okay, and how can I ask the LLM, and how can I get a response from the LLM and calculate my cost? Okay, I hope you enjoyed this video. Okay, I hope you, if you like this video, I hope you like the video. If you have any question, you can comment on the video, and please subscribe on my channel so that you can follow up the next videos we upload on the same channel. Thank you.